I'm standing next to two very important geological features here in the rocks that you probably ignore. Do you want to know what that thing is? I'm going to tell you. See, it's vertical and it's cutting through the rocks. What does that indicate? That indicates that that rock there is a magma. And this magma, when it's been a melt, as in a magma in the crust, is basically cut through these rocks and intruded into them, forming what's known as a dike. That's what this rock is. It's vertical and it's known as a dike. Now, it's cool because the rock here that I'm standing on is 61 million years old, and then this rock here is 600 million years old. There is a gap in time between that and that rock that I can touch right there. The rocks that I'm standing on are metasedimentary rocks. They're part of the Dalradian supergroup, right? What's the Dalradian supergroup? It's a set of metasedimentary and meta-igneous rocks that formed back 600 million years ago. Originally deposited as sand, silts and muds into the Iapetus Ocean, which is now long gone. These rocks have been metamorphosed and put under pressures and temperatures that have caused them to change, and that's what metamorphism is. So as you had the Caledonian orogeny around 390 to 490 million years ago, the two plates collided with each other and the oceanic crust subducted under the continental crust. Scotland back then was situated on a continent known as Laurentia, and these rocks ended up in this collision course with these two continents. England was on Avalonia, Scotland was on Laurentia. So as that happened and you had the collision of the two continents, these rocks, metasedimentary rocks here that I'm standing on, originally shales and some limestone here at the back, because this is now marble and this is now slate, been metamorphosed to change into the rocks that we see today. Because the metamorphism as well allows different chemical reactions in it, and the minerals grow and recrystallise over geological time. I'm talking millions of years here. This causes a slaty cleavage to form, and that's why slate's so durable and splits along different planes, and that's why we use it as a roofing like material, because it's, you know, or we did use it as a roofing material because it's easy to build with and it's durable, impermeable. So pretty cool rock, pretty strong rock in this. Now the other interesting feature that I'm standing next to is this rock here. This is quartz. This is a quartz vein that's running through the rock. How do you think this formed? I'm going to tell you. This quartz vein formed when you had hot hydrothermal fluids, which were probably magmatic in source, running through the rocks, running through cracks in the rocks, which would precipitate out minerals like this, like quartz or calcite, or even sometimes gold in certain areas across the highlands. They're very randomly orientated. Sometimes they can be in the same orientation, but they'll split through different discontinuities, different fractures in the rock. This rock here that's the dike is basaltic in composition. That's the first magma that forms when you have a partial melt of the crust. Absolutely class. Rich in minerals such as pyroxene, olivine and plagioclase. And basically is that first magma that forms, right? So that's what that is. Its reason it's orange as well is because it rusts when it's at the surface. The minerals aren't happy, so they rust away. Anyway, that's it. We're going to stop recording and go home.